Good morning and welcome to this discussion. We've been given this equation and they want us to obtain the Fourier series of this function. The function is given by f of x equals to pi plus x in the range of from negative pi to 0, and then we have pi minus x. This one is in the range of from 0 to pi. Then our f of x plus 2 pi is equals to f of x, meaning that this one is a function, of course, with the period pi, and the function repeats itself after 360 degrees. That's why we have 2 pi here. Now, for us to get the Fourier series of this function, of course, we know that Fourier series is given by a naught over 2 plus summation from n equals to 0 to n equals to positive infinity. Then we have an cos nx and then plus pn sine nx. So this is what we are calling the Fourier series. Now, from the given information, which I required to get a naught, to get an, and then to get pn. Once we get them, we come and insert this expression. We will have obtained the Fourier series. Now, we shall start by trying to find the value of a naught. So a naught is given by that. That is the formula for getting our a naught. So from the given information, so we are integrating in this interval. We are integrating from negative pi to 0. So we have from negative pi to 0. And what is f of x? F of x in this interval is pi plus x, then of course dx. But remember, we have two intervals. We have this and that. Therefore, we shall have plus. In that interval, we are integrating from 0 to pi. What is f of x in this interval? It's pi minus x, then dx, like that. Okay, so this equals to 1 over pi into, now, we now integrate pi plus x. So when you integrate pi with respect to x, we get pi x. When you integrate x with respect to x, we get plus x squared all over 2. But the range, that is we are integrating from negative pi to 0. So we have that. Then plus, when you integrate pi with respect to x, of course we have pi x minus x squared all over 2. That is the range of integration, like that. Mirror up here. Now from here we can now insert the given limits. So our a naught equals to, of course, 1 over pi into, now where there is x, we substitute with 0. We take the upper limit minus the lower limit. So we shall have here pi dot 0. Replace this is x by this. Then plus, now we shall have 0 squared all over 2 then we close the bracket, then minus, we now substitute the lower limit. So here we have now, it will be x, when there is x, we put there negative pi. So negative pi times pi, we have, we shall have negative pi squared. Then here we have, of course, plus, then this is x, we put there negative pi, so negative pi squared, so it will be pi squared all over 2, like that. Then plus, so here we substitute with where there is x, we put there pi, so here we shall have pi squared, then minus, so here you will have minus pi squared all over 2, then minus, we now substitute, we subtract the lower limit, we substitute with the lower limit, so when there is x, we put there 0, so you can realize that it will be minus 0, because this will be 0. When you substitute where there is x with the 0, everything becomes 0. So this equals to 1 over pi into, so this is 0, you can see, so it will be 0. Then here we have this minus and that minus, it will be positive here, so we shall have 0 plus pi squared, and then this one minus pi squared all over 2. Then here we have plus pi squared minus pi squared all over 2. We wrap this again. Now this equals to pi all over 2. So here we have this pi plus that pi. What do we have? We have 2 pi squared minus a half pi squared minus a half pi squared. It is now minus pi squared, like that. Therefore, this equals to 2 pi squared minus pi squared will remain with pi squared. Therefore, this equals to pi squared all over pi, this pi. So this and that will cancel, and then will remain with pi. Therefore, we are saying our A naught equals to pi. Our A naught equals to pi. Therefore, we have gotten the value of A naught, this one. So we now need to proceed to get AN and also get PN. Now, our AN is given by 1 over pi into the integral of f of x cos nx dx. That is the formula for getting AN. Therefore, AN will be equal to 1 over pi into, now remember we have two intervals that we are performing integration. We have this interval and that interval. So we shall have the integral of, from the first interval, which is from negative pi to 0. What is f of x in that interval? F of x is pi plus x. Pi plus x. And then we have now cos nx dx. Cos nx dx. That is the first interval. And then in the second interval, plus. Now the second interval, which runs from 0 to pi. What is f of x in that interval? Pi minus x. Of course, we have now cos nx dx. That is it. Therefore, we now need to integrate this and that in order for us to be able to get the value of an. Now, but as you can see here, there's no way you can perform integration of this without using integration by parts, which says that uv minus the integral of v du, that is the integration by parts formula. So we need to apply this formula to be able to perform integration at this point. Therefore, pi plus x will be our u, and then cos nx will be our dv. That will be our dv. Therefore, we need now to differentiate this equation. What we are saying is that I can do it here, that u equals to pi, u equals to pi plus x. So you differentiate u with respect to x, that is du dx. When you differentiate u with respect to x, then we have 1. When you differentiate this pi with respect to x, you get 0. When you differentiate x with respect to x, you get 1. So du dx equals to 1. So if that is the case, therefore we are saying that du equals to dx. Du equals to dx. And then here we are saying that dv equals to cos nx. Now, for us to get the value of v, we integrate both sides of this equation. Okay, so we integrate here and then we integrate there like that. So when you integrate dv, you get v. When you integrate cos nx dx, you'll be able to get sin nx all over n. Okay, now from here we are through with this and we perform the same. We need to also differentiate this one and also integrate that. In other words, we are saying we let this be our u, that u equals to pi minus x. Then we differentiate u with respect to x here, so it will be du dx. When you differentiate pi with respect to x, you get 0. When you differentiate negative x with respect to x, you get negative 1. So du dx equals to negative 1. So we are saying that at this point, du equals to negative dx. Du equals to negative x. And then our dv, because nx, but you can see that this one is the same as this one. So v at this point is the same as that one. In other words, it is sin nx over n. Now, once we have the value of v, we have the value of u, and we have du, we can now come and substitute in this formula. Okay, let me wrap here. Now, what we are saying is that our an equals to, of course, 1 over pi, this pi. Okay, now all of this, we are now applying this formula. So we ask ourselves, what is u at this point? U is pi plus x. So pi plus x. Then what is v? V is this one, sine nx over n. And the integral is from negative pi to 0. So we have from negative pi to 0. But we are not through, then we have minus from negative pi to 0. What is v? V is sine nx all over n du. Du, we are saying that du equals to dx. Therefore, this will be dx. So we are through with this section. Then we need to come to this section again. I can now wrap this. Then plus now we are here. So also here we apply the integration by parts. So what is u at this place? U is this one, which is pi minus x. Pi minus x. What is now v? V is the same, sine nx all over n. Then we are integrating from 0 to pi minus the integral of 0 to pi. We are now in this integral 0 to pi. Our v there is sine nx all over n. Then du equals negative dx. So here we have minus dx. And you need to be very careful with the signs, because they can easily mess you up if you are not careful. Now we have now written everything. I can now wrap this. Can now wrap that. Now I want to do reorganization of this. So this will be equal to 1 all over pi. Then I want to write this one as, remember I have 1 all over n here, so I want to take it out a little bit. So I have 1 all over n, then pi plus x sine nx, then that is the range. Then from here, you can say I have 1 all over x, I want to take it out of the integral sign. So I have minus 1 all over n, the integral of from negative pi to 0. Now I have sine nx dx. That's fine. Then plus, I want to take 1 all over n outside here, so that I have 1 all over n into pi minus x sine nx. That is it. Now here, I also want to take 1 all over n outside. But remember, I have this negative sign. I want to take it out, so that a negative now, this one will turn out to be positive. Therefore, I have plus. Take out 1 all over n, the integral of from 0 to pi, and then I have remained with the sine nx, then dx, like that. So once I have done the reorganization like that, so what is remaining is for us now to integrate this and integrate that, and then move on. Now this equals to 1 over pi, and of course I have 1 over n pi plus x sine nx minus 1 over n. Now, when you integrate sine nx, so here we get we shall get minus cos nx all over n. And of course, that is the range of integration. When you integrate sin nx, you'll be able to get negative cos nx all over n. Then plus 1 all over n into pi minus x sin nx, then plus 1 all over n. When you integrate sin nx, you get minus cos n x all over n. That is the range of integration. Can now wrap this. Okay, I can do a bit of reorganizing this again. So an equals to 1 all over pi into, so here I still have 1 all over n into pi plus x sin nx in the given range. And then here I can take out 1 all over n, and then this sign and this sign will be positive, so I have plus 1 all over n squared, because now when you take n outside, take this n times that n, so it will be n squared, and this will be positive. So I have that cos nx, and the range is, that is it. And then I have plus 1 all over n pi minus x sin nx by 0. Here I will take 1 all over n outside, but again this sign and this one, positive and negative will be negative, so I have minus, then take 1 all over n outside, so we have 1 all over n squared, 1 all over n squared into cos nx, then from 0 to pi. So that is it. So I've done with the integration. So what is remaining now is for us now to substitute the limits. Now, from here, when we substitute the limits, when you are very careful, you realize that because we start with the upper limit, where there is x, you substitute with the 0, then minus, you substitute now with the lower limit. So you realize that sine 0 here, sine 0 will be 0, then sine, where there is x, when you put it there, pi, sine 180. You can confirm that with your calculator. Sine 180, it will be 0. So whichever, when you substitute with the upper limit with the 0, then minus the lower limit with the pi, so you realize that this, because of this sign, this will be 0, and again that will be 0. Where there is sine nx, it will be 0 at the end of the day when you substitute. Therefore, at this point, then we remain with this and that, so that we have our an equals to, remember we have 1 all over pi into, now here we remain with 1 all over n squared cos nx, the given range, and then of course we have minus 1 all over n squared cos nx in that range. Because n squared is common, we can take it out. So so that we have this equals to 1 over pi n squared into, so here we remain cos nx, that range, then minus cos nx, the given range, Can rub here again. Now this equals to 1 over pi n squared into, we now substitute the limits, so we have cos, where there is x, you put it as 0, so it will be 0 times n, so we have cos 0 minus the lower limit, so it will be cos, where there is x, so it will be minus n pi, then minus, we now have this, where we have cos n pi, then minus cos 0, like that. So once we have that, I can rub this, that. So this equals to 1 over pi n squared into cos 0 is 1, so we have 1 minus cos minus n pi. Then I have minus cos n pi, then plus negative and negative, it plus cos 0 is 1. So this equals to 1 over pi n squared into 1 plus 1. I have 2, then minus, then you realize that cos minus n pi, this, we know that cos minus pi is the same as cos, pi. Therefore, we can write this one as, minus cos n pi minus cos n pi. Therefore, this equals to 1 over pi n squared into 2 minus 2 cos n pi. Therefore, we can factorize out 2 because it's common, so that an equals to, now it will be 2 over pi n squared into, now we have 1 minus cos pi n. Can rub this. Now, at this point, we now test for even and odd function. So when we are testing for odd function, we let our n, we normally test when n is 1. And then for even, when n is 2. Now, we shall say when n equals to 1, our an will be equal to, so here we shall have 2 all over pi n squared into 1 minus, so we are saying that when n is 1, so here it will be cos pi, so it will be 1 minus cos pi. Cos pi is the same as cos 180. What is cos 180 when you use your calculator? Cos 180 is negative 1. Therefore, this will be equal to 2 all over pi n squared into now 1 minus 1, which equals to 1 minus is now positive. So it will be now 2 times 2, which is 4 all over pi n squared. So we are saying that our an equals to 4 over pi n squared, but when n is odd, when n is odd, we want to consider when n is even. When n is even, our an will be equal to 2 over pi n squared into 1 minus cos. Now n is 2, so this will be 2 pi, it will be minus cos 2 pi. Cos 2 pi is the same as 360. So you get cos 360. Cos 360 is 1. So meaning this equals to 2 all over pi n squared into 1 minus 1. We are saying that this is 1, which equals to 0. So we are saying that at even numbers, there's no series. An equals to 0. Therefore, we are saying that an equals to 4 over pi n squared. N is odd. That is, we shall be dealing with 1, 3, 5, 7, 9, like that. So we have an. So we now remain with getting the value of Pn. Pn is given by 1 over pi. We are integrating from negative pi to 0. Our f of x there is in the first interval, it will be pi plus x, then sine nx dx, then plus the second interval, integrating from 0 to pi minus x, then sine nx dx. So once we have done this, we now need to integration by parts. So this will be our u, this will be our dv. So here we have u equals to pi plus x du dx equals to 1, meaning that du equals to dx. Then dv here equals to sine nx. Therefore, to get the value of u, integrate this. Okay, dv equals to the integral of sine nx dx. So when you integrate dv here, you get v equals to, and then here you have, when you integrate sine nx, what you get? When you integrate sine nx, you get cos nx over n. Sine nx is cosine, so this will be minus. When you integrate sine nx, you get minus you get minus cos nx. And then here you have your u equals to pi minus x. So du dx equals to minus 1, meaning du equals negative dx. And then the value of v is the same as that one. So once we have now uv du, we can now substitute in this formula. Can wrap this. I can write it below here, so that I have 1 over pi into, now here we have our u, which is pi plus x, then v is negative, so I have minus, I can start with that minus here, cos nx all over n in the range of negative pi to 0, then minus, our v there is minus cos nx all over n du equals to dx, so we have dx like that, so I'm through this, then I move to that part. So my u here is plus that sign, pi minus x, and then v is negative cos x, so I have plus minus, I start with this negative sign, cos nx all over n, so the integration range 0 to pi minus 0 to pi, my v is minus cos nx all over n du negative, so I have minus dx. So you need to be very careful with the sign. So once I have written this, we can now move on. Let me wrap this. Now wrap this. So this equals to, I want to take 1 all over n, so that I have minus 1 all over n pi plus x, then cos nx, then this negative and this will be positive, plus, then you take out 1 all over n, the integral of from negative pi to 0, so inside here will remain the cos nx dx, then I'm here plus minus, so here it will be and here we need to be very careful with these signs, or this is okay, plus minus, so here it will be minus, take out 1 all over n pi minus x, then cos nx from 0 to pi, then I'm here, so this sign and that will cancel, so this will remain minus 1 all over n, you take out 1 all over n, then we remain with integral of from 0 to pi cos nx dx, like that. Now we need to finish up with the integration. We are remaining with this part and that part before we start substituting in the limits. So we have 1 over pi into minus 1 over n pi plus x cos nx, then when you integrate cos nx, when you integrate cos nx, we shall be able to get what? Sine nx all over. So we have plus 1 all over n. When you integrate cos nx, we get cosine nx all over n. And then we have the range, negative pi to 0. Then we have minus 1 all over n into pi minus x cos nx. Then when you integrate that, we have plus minus 1 all over n into sine nx all over n pi to 0. That is the range. So this equals to 1 over pi into minus 1 over n pi plus x cos nx 0 negative pi. We take n out, 1 over n, so that we have plus 1 over n squared into sine nx minus 1 over n into pi minus x cos nx. That's the range. Then we take 1 over n outside, so we have minus 1 over n squared into sine nx, like that. So from here you realize that when you substitute with sine, when we shall be substituting where there is x with 0 and pi, so all sine function will give us 0. Will give us 0. So we remain this function and that function. So our Pn then will be equal to 1 over pi into, we now have minus 1 over n into pi plus x cos nx negative pi. Then we have minus 1 over n pi minus x cos nx. Like that. Can now wrap this. I can take out negative 1 over n because it's common. So this equals to 1 over minus 1 over n pi into, now I have pi plus x cos nx. Then I have plus pi minus x cos nx, like that. So minus 1 over n pi, now we substitute with the limits. So where there is x, start with the upper limit, so here I'll have pi plus 0, then I have cos, now 0, minus, now here you have pi plus minus pi, so you have minus, and then you have pi minus pi cos negative n pi. Then here we have plus, so you have pi minus pi cos n pi, like that. Then you have minus pi minus 0, then cos 0, cos 0. So this equals to -1 over n pi into pi. So cos 0 is 1 times pi, so here will remain with pi. Minus this is 0, pi minus pi is 0, 0 times everything, it will be minus 0. Pi minus pi is 0, so this will also plus 0. So here you have minus pi, so this is 1 times pi, so we have minus pi. So we have pi minus 0 plus 0 minus pi, so this pi and this pi cancels, so that everything becomes 0. So you have this times 0, which equals to 0. So we are saying that Pn equals to 0. So once we have all this, we now have the value of A0, An, Pn. We can now state our Fourier series. Now Fourier series equals to, now our A0 is pi. Remember this was, so it will be pi over 2, then plus. Remember Pn is 0, so we have An. We are saying that An equals to 4 over pi n, but remember when n is odd, so we shall consider 1, 3, 5 odd numbers, so it will be equal to, so we shall have 4. I want to retain 4 over pi outside the bracket, then I will take inside 1 over n squared. 1 over n squared goes inside the bracket. So we consider when n is 1. When n is 1, so we shall have 1 over 1 squared cos n is 1. So here we shall have cos x. Then plus. We have considered 1, then we go to 3. So it will be 1 over n squared. So n is 3. So it will be 3. So it will be 1 over n squared. So it will be 1 over 3 squared. So it will be 1 over 9 cos 3x. We go to 5. 1 over n squared. So it will be 1 over 5 squared, which will be plus 1 over 25 cos 5x. So from 5 we go to 7, so it will be plus 1 over 49 cos 7x plus, and it continues like that. So this is what we are calling the series, the Fourier series of this function. So the most important thing with the Fourier series, you need to be patient, be very keen with the minor details, especially signs and brackets. This is where we normally have, where students normally make mistakes. But when you are patient and very keen with the minor details, you'll be able to come up with the Fourier series of any given function. Thank you for watching and listening. Bye bye.